Okay, so I'm coming, or our regional development center is situated in the municipality of Koper, and as you can see on the map on the left side, the municipality of Koper is situated in the southwestern part of Slovenia. It is underlined with a red line. This is the biggest municipality of our region. It's the coastal Kart region. That has 8 municipalities, and this region is the only Slovene region that has access to open sea. And in our municipality, all the most important regional institutions are situated, as well as the port of Koper, the most important, one of the most important northern Adriatic ports. And in our municipality, there are 52,000 inhabitants. And in within the Impulse Plus project, 48 public buildings were included in the study, and they have been divided into 11 typologies. And we have chosen 4 classification criteria, which are use of the building, and this was educational, administrative, cultural, and entertainment buildings. And then the next criteria is year of construction, number of floors, and surface. And among 11 typologies, 5 have been selected, and also 5 ambassador buildings that you can see here on the photographs. In the upper row, in the middle, there is a kindergarten or nursery school in Bertoki. This is a small town situated near the city of Koper. And on the right, in the upper row, there is a primary school in Prade, also a small city situated near Koper. And in the bottom row, on the right and in the middle, there are 2 administrative buildings. The right one is the former municipal department, and in the middle, Consulate General of the Republic of Italy. And on the left, you have the entertainment building. This is Arena Bonifica. It has the biggest sport hall in the region. We have adopted 4 retrofitting levels: minor, medium, major, and deep. And for each retrofitting level, only 1 scenario was taken into consideration because of limited time. And proposed measures when elaborating scenarios were the following. For minor retrofit, a replacement of lighting with modern LED lighting, and installation of dynamic valves with thermostatic heads on the radiators. For medium retrofit, we have foreseen a thermal insulation of the facade or ceiling or basement. And for major and deep retrofit, installation of new windows, doors, of solar power plant, and of central ventilation system with heat recovery. And here you can see some results of impacts of scenarios tested. For example, this is the example of kindergarten or nursery school Bertoki. If deep retrofit scenario would be implemented, the primary energy consumption in the chart on the left side would be 0. And the same goes for CO2 emissions. You can see it on the right. And the next example is the Italian consulate. If we would make a deep retrofit of this building, the results wouldn't be so optimal because this building is situated in the city center, and this is the area under cultural heritage protection. Therefore, not all the measures could be implemented foreseen in the deep retrofit scenario. For example, the thermal insulation of the facade couldn't be made. And therefore the results are not so optimal, but in any case, the savings are obvious. Here is our presented weighting factors of the plug-in tool. As you can see, we have chosen, or we have put the most weight to the total annual primary energy consumption. So this is the reduction of energy consumption was the most important for us. We have chosen the second public building typology as more important. These are educational buildings built between 1980 and 2002 with less than 1,000 square meters surface and up to 2 floors. And as relative annual retrofitting area, we have defined 0.75%, which is less than 3%. And that's because our municipality usually can renovate yearly 1 or 2 buildings at the most. So this is a realistic percentage. Targets that have been defined are those set in municipal SECAP and local energy concept. And annual investment foreseen is 5 million euro. And here you can see the results for the period by the year 2027. Regarding the goals reached, we can say that at the end of this period, in the year 2027, energy consumption would be reduced by 63% and CO2 emissions by 60%. So these two targets would be absolutely met and also exceeded. The use of primary energy consumption from renewable energies wouldn't be met. This goal wouldn't be met. Our goal that was set was 25%, and here we would reach 8.6%. And here is our financial tool. That would follow the numbers which are presented here, follow the call of the Slovene Eco Fund that offers loans to public institutions for complete renovation of public buildings. And we have chosen 3 combinations. We have defined 3 combinations, and differences are among interest rate of the loan and annual increase of loan rate that follow the forecasts of Euribor increase, and also the differences are in energy discount rate that has been defined following EU guidelines. And here are the results. We can see that the most convenient option is to take one complete loan, but the differences are lie upon the energy discount rate. So this rate has big effect upon results, and we can see that the gap between no investment and investment carried out in the combination number 1 would emerge in the 21st year. And in the combination 2, this gap would emerge in the 10th year. And in the combination number 3, this gap would emerge in the 7th year. For conclusion, I may say that our municipality finds this tool very useful for a quick estimation of investments to be performed. So to make an order of priorities of renewal of public buildings in the next years. And this would be a good baseline for the budget planning of budget that is performed by our municipality. So we are very pleased that we had the opportunity to take part in this project, and that we have got familiar with these tools, new tools that are not known in Slovenia, and we intend to present them also to our other municipalities and our regions because we find it very useful. Thank you. That's all from my side.